This is video 1 of a two-part video series on offsets. This is section 1 of video 1. Say we wanted to do a simple offset with 90-degree fittings. You'd just measure from the center of this pipe to the center of this pipe, remove your takeouts, cut your filler piece, and you'd be done. Let's suppose you couldn't get this center-to-center measurement because maybe you're in an office building. And let's assume that this pipe is 6 inches off the wall, but there's an obstruction on the other side of this wall you have to miss. So you need to move this pipe to 2 foot 6 inches off the wall. So we'd take the 6 inches from the 2 foot 6. Now we know the two pieces of pipe are 2 feet apart. And we'll say this one is 6 inches down, ceiling to center, and this one is 1 foot down, ceiling to center. That would mean this pipe is 6 inches lower than this pipe. So we have 6 inches by 6 inches, and this pipe here would be 1 foot down, 2 foot 6 off the wall. To make it simple, 6 inches is a half of a foot, or 0.5. So we'd say 0.5 squared plus 2 squared will give you c squared, which will be the dimension center to center between these two pieces. So it's the Pythagorean theorem. You have A, B, and C in your triangle. So we'll take A and make it squared. So A squared plus B squared equals C squared. So if A is 0.5, you go A squared and then 2 squared will give you C squared, but we don't want to know what C squared is. We want to know what C is. So you'll take the square root of your answer, of your C squared answer, and that will be your measurement center to center between these two pieces of pipe. That concludes part 1 of this video. Now let's say you're going to do a rolling offset. This green box I have there is just a training aid. You'll see in a minute. Just ignore it for now. Let's assume you're coming out of a mechanical room. Here's for the new wall start, but there's stuff back here and you had to be here for duct work or something. So you're coming along and, well, here's a big piece of wood, a register, soffit, whatever here. We have to miss that, and they don't want us to stay down low because they're going to hit their heads because they're going to have a file cabinet under here. So for whatever reasons, we have to use 45-degree fittings. Now you may have to use 22.5. 22.5s are a little bit different than what I'm going to show you. There's some different ratios in those formulas, but for the purposes of doing a rolling offset using 45s, we simply use the Pythagorean theorem twice. So what I mean by that is when we're coming along the wall, we're so far off here, so far off here. So we got to go up and we got to go over so far. So we have our distance from the ceiling to the center line of this pipe. We have our distance from the ceiling to the center line of this pipe, wall to center, and wall to center. So you'll measure this, subtract this, and it'll give you this dimension here. And the same thing happens. Subtract this dimension from the ceiling, and then subtract it from this dimension of this pipe from the ceiling. So we'll call this side A. So if you were using 45s, we'd have side A, side B, and our hypotenuse, step 1, would be C. So A squared plus B squared equals C squared. Now when we do that, we found this dimension right here. So what that means is we've removed part of the box. Now what we have left to do is to find this portion. Just so happens a rolling 45-degree offset is the easiest of the offsets, because a squared plus b squared equals c squared. So you find the c dimension. If you're using 45s, this is actually the same as this. So this c dimension would be the same as this c dimension. So you'll insert this, now becomes side A and side B. So a squared plus b squared equals c squared, and there's your travel piece. So it's a two-step procedure for a rolling offset. A squared plus b squared equals c squared. This side doesn't change. Simply rotate it. And now you have a squared plus b squared equals c squared. And that is your 45-degree rolling offset. Like I said, 22.5s and other fittings, you're going to have to use the table in your book, and your instructor can go over them with you. Thank you.